Hello, my name is Carlos Gavidia, a PhD graduate from University College London. Today, I will present the paper we published last year at the Journal of Systems and Software. Software development is still a human-intensive enterprise. People involved in it have different interests, and they are not necessarily aligned with organization goals. What is worse, the organization's software development process can be the cause of this misalignment. The XC paper featured in the slide illustrates one of these situations. It studies an organization whose development process favored feature delivery over code quality. It mentions a software issue affecting the work of 12 teams at different times. Given the incentives in place, the 12 teams developed temporary workarounds. Collectively, they invested 60 person days. In contrast, building a permanent fix would be significantly cheaper, requiring only 20 person days. We believe many software processes suffer from such incentive problems. We propose to use game theory to identify such problematic processes, to then improve them by aligning their incentive to the organization's needs. In this slide, we're using a payoff table to represent the scenario we just described. It models two players, the developers, that interact via two actions. The fix-intensive action favors fixes. They take more time, keep a healthy code base, and are unlikely to require rework. In contrast, the clutch-intensive action favors clutches. They are faster, degrade code base quality, and are rework-prone. A table cell contains the player's payoff given their actions. In this case, it is the expected number of features released. The equilibrium analysis of this model can predict player behavior. For this payoff table, it outputs that both developers adopt the clutch-intensive action. However, if incentive favored an equilibrium with the fix-intensive action, the team would have released 2 additional features. To enable game theoretic models to scale, we adopted empirical game theoretic analysis, or EGTA. EGTA abstractions are payoff tables with payoff values obtained via simulation. We start by building and validating a simulation model of the process to improve. Using this model, we can experiment with interventions to see the effect they have in equilibrium behavior. In the slide, we see the simulation model of a process that moves equilibrium towards the fix-intensive action. By including code analysis and code review, we made clutches more expensive and less attractive to developers. Thank you very much for listening, and I invite you to read our paper.